All right, so let's look at number 7 from the cognitive homework. All right, in this question, distance is measured in kilometers and time is measured in hours. On a given day in a certain coordinate system, the position of a car at 2 p.m. is at negative 53, 192. So this is, my position at 2 p.m. So, I'm not trying to get a perfect sketch here. I'm just trying to get a sense of what's going on. So at 2 p.m., I'm a little bit to the left and up here. So we'll call that my 2 p.m. position. And then at 5 p.m., I'm over here at negative 164. So further to the left and up at 279. So this is where I'm at 5 p.m. So I kind of know which direction I'm going. I know my velocity vector is kind of going up and to the left, like so. All right, so let's keep reading. The car is moving on a straight line with constant speed. That's going to be true for all these vector questions. But we know that tells us that, in the past, it's been coming from this direction. Which one of the following equations describes the position of the car t hours after noon? So what they're really asking you to do is to write a vector line equation. So r equals position vector plus t times direction vector. This is what they're asking, or velocity vector in this case. All right, so let's do that. All right, so the first thing we need to do is we're going to need to find the velocity vector. Well, we have the velocity vector here. Now, this is how, this vector shows the position traveled or the distance traveled in 3 hours. So if we find this vector and divide it by 3, we're going to have our velocity vector. Our position vector, we have to take based on what the question asks us. The question wants us to write an equation describing the position of the car t hours after noon. So we have to figure out where the car was at noon. So somewhere back here, but we're going to have to find that mathematically. And that's going to be the position vector. So let's start with the velocity vector. To find the velocity vector, I'm going to find this vector. So I'm going to use n minus start. Okay, so I'm doing n minus start in the x's, negative 164, minus a negative 53. And then 279 minus 192. And when I do that, I get negative 111 on the top. And down below, I get positive 87. So that's this vector. That's the direction vector. But to convert it to a velocity vector, I need to divide by the number of hours. So I need to multiply velocity vectors 1/3 times this vector. And when I do that 1/3 times 111, you might think it doesn't go in, but it does. It's 37. And, negative. And 1/3 times 87 is 29. So here's my velocity vector. I just figured out what goes on in this part of the equation. So now I know that this is how much I'm going every single hour. I'm going negative 37 to the left and 29 up. So I can easily work backwards to figure out where I was at noon. So at 2 o'clock, I was here, right? I was at negative 53, 192. And I just need to subtract 2 times the velocity vector to figure out where I was 2 hours ago. So working through this math, once you have the setup, it's not that bad. Negative 53 minus 2 times negative 37. That's plus 74. Positive 192 minus 2 times 29. That's minus 58. So I get 21 and 100 and, what is this? 124, I hope. No, 134. That looks better. Okay, so 21, 134. That's where I started at noon. So my equation is r equals 21, 134 plus t times the velocity vector, like so. Again, just like when you wrote equations of lines back in Algebra 1, you've always got a y and an x. When you're writing vector equations of lines, you're always going to have this r and t, like so.